Hi everyone, welcome to the supplemental material for my final project. My final project is a case analysis of the ransomware WannaCry, which utilized the EternalBlue exploit developed by the NSA to target Windows servers and gain access remotely. So for my supplemental video, I wanted to do a couple of things. I first wanted to show how EternalBlue gained access to these Windows servers through metasploit. And then I also wanted to try to extract some files from an executable binary I found of a live code sample of WannaCry, just to get a little bit more of a technical understanding of the software itself. So in order to do that, I'm first going to start with the EternalBlue exploit. So let me just start up my terminal. So the things you want to know in order to do this is you want to first ensure that your Kali Linux and that your Windows server are both on the same internet connection. I took the liberty of checking that already. I also took the liberty of checking the IP addresses for both, just to ensure that, actually, now that I'm here, let me check it one more time, but just to ensure that this goes smoothly. But you want each of these, so yeah, this is still accurate, as is, I'm sure, this one. And so this is used when sort of figuring out what the target is, where we want to return all the information that we're looking for, etc. So yeah, so nothing has changed. So I'm just going to initialize and start the database. This is going to help with port scanning. So now that this is set up, I'm going to start running the console. So let me just close out of this. And yeah, perfect. So the framework is being set up currently. Okay, perfect. So let's do an nmap scan of the IP address of our target. We can see through this which ports are open and which ports are vulnerable. So you can see here 22, 135, 445, and a couple others are open. The EternalBlue exploit utilizes a vulnerability in the server message block protocol, so SMB port. So the SMB protocol is conducted over 139 and 445. So we can see here that 445 is wide open. So this is definitely vulnerable to an SMB exploit. So let's search for an EternalBlue exploit in metasploit. And here we have a couple that we can find. There's right here and there is right here. So my Windows server is actually Windows 7. So we don't want to use Windows 8 because that wouldn't actually run the exploit. So we're going to use this one instead. So we want to use exploit Windows SMB MS17 EternalBlue. And so we're now using that exploit, and let's see what options are set up. So currently we have the port as 445, which is great because that's our vulnerable port. We want to set the remote host, to our target because this is where we are running the exploit and attacking. Perfect. So now we want to set our local host to our own, or not local host, listening host to our own IP address so that we can be retrieving the information that we get from whatever remote code that we execute. Okay. And then last, we want to set the payload, which is the code that gets executed once the exploits run, to use Meterpreter, which is an attack exploit or attack payload that's set up by the Metasploit framework to assist with running attacks and running different commands on your target. So Meterpreter reverse TCP. So now let's just show all the options. Everything looks good to go. I will say on occasion this does fail. So just bear with me. Usually if it does fail and I run it again, it does work. So let's see. Let's hope the first time this all works out okay. Okay, so it's triggering free of corrupted buffer. This will take a little bit of time. If it is taking time, that means it's likely going to fail. We'll see. Worst comes to worst, I'll run it again. And if not, I can just cut in a new image of it, you know? So yeah, this definitely looks like it will fail, and it did. Hopefully the next one will work. If not, we'll run it again. Okay. So it doesn't look like this time it's going to pass either, tragically. So yeah, it failed again. Let's see if it works this time, and if not, I'll try running again. Okay, yeah, so it failed. Usually after the third time it does work. See, yeah. So I'll try running it one more time. Okay, in the meantime, as this is running, I want to go ahead and show in another terminal the WannaCry binary code that I found on GitHub online. So that's in this WannaCry code excuse me, file. So let's just go, directory. And let's see, we have this tar file, so let's just open that up. All right, so within this we have a new folder that was made called WannaCry Sample 0. Okay. And so here we have a README, and then we have the executable. So typically an executable doesn't have a lot of information that can be extracted from it, but let's unzip it and see what we can find. Okay, so it's asking for a password. I have the WannaCry password written here. It is WNCRY at 20. Ooh, what happened to our... Okay, interesting. That seemed to do something odd. Let's return to that in a sec. But okay, so as you can see here, we have extracted a series of files with a .WNRY extension, and this is a file extension specific to this WannaCry ransomware. If we look at it in folder, we can notice that some of these are actually types that we may recognize. So all it takes is really renaming this to, let's say, a JPEG. And opening that up, let's see what it is. Right, so this is a page that pops up if an antivirus software deletes the decryptor service that ransomware downloads and installs on the device. So this is sort of giving the examples, and this is hard-coded into the all the files that get downloaded on the off chance that the decryptor is deleted. Let's see. Oh, so we noticed that S is a zip file, so let's try to unzip that. Okay, so it gives us a bunch of dynamic linked libraries that are in the Tor folder. So here we have this Tor folder that got unzipped from the S WNRY file extension file. So within Linux, I don't have any applications that can open a dynamic link library, but we can do, for just our own viewing purposes, change this to a text and sort of see what we can decipher from it. So it looks like it's string comparing down here. It's getting information. This looks like it might be the one that goes through files and copies them in order to encrypt them and then to remove the original copies. And so each of these dynamically linked libraries, so Meterpreters actually also utilizes dynamically linked library because it's able to remotely use memory to conduct remote execution. So this is the same idea with the WannaCry software. It uses dynamically linked libraries, so it doesn't need disk space on the actual target. And if we go into message, we can see there are 28 different items in here, and each one is a different language. So what's in these files is more so let me see if I can change this so I can open that up and show. This is sort of instructions of what's happened to the victim's files, how do they get it back, where they need to send the information. Okay. We strongly recommend you do not remove the software and disable your antivirus for a while, etc., etc. If we look at, let's say, what other language do I know? Spanish. Mejor hora para consultar, so when's the best time to be reaching out for Bitcoin, things like that. It seems like these are all direct translations of each other, and so this kind of shows the scope of what WannaCry is intended to be and what it was. So I want to change a couple more. I want to change this one to a text file just so we can view it. So if you see here, these are actually the addresses that were supposed to be used through Tor to generate a Bitcoin address for victims to use to send the ransom in. But there was a bug in this part of the code, so what WannaCry does instead is it hard codes the Bitcoin address into a file, and then once that ransom is paid, it goes in and replaces that with a new unique Bitcoin address. The last thing I want to do is sort of look at this one, see if there's anything in here. So this, as you can tell by the header, is actually the WannaCry encryptor file. So what this does is it this is what actually goes through each file. It searches through a specific series of extensions, so doc, PowerPoint, PDF, pretty much any common one that you can think of, and it actually encrypts it using this encryptor. And what the decryptor does then in response is, once the ransom is paid, it returns a encrypted private key for this encryptor to the victim, and then once the ransom submission or the payment is validated, it decrypts that and then executes that on each of the files that had been decrypted or had been encrypted. So this is sort of an understanding of the code itself. Although we can't extract it fully because it is an executable, there are different pieces that give insight to WannaCry as a whole. So there is one piece missing from this WannaCry software, and that's the dropper part of the code. So the dropper is essentially what copies all of this information and runs the executable on a device. The dropper itself first searches for a specific URL, and upon the condition that URL does not exist, will then execute the code. So that's meant to be the kill switch for this software. So that about sums up what can be extrapolated from the binary from the live code. Let's return now that something happened with our Windows and it seemed to shut down, but let's see now if we can return back to our exploit and see if it works. So everything still seems to be in order. Let's run it and see what happens. So giving it a second. Okay, triggering free of corrupted buffer, that's good. Okay, this one also looks like it's taking a little bit of time, so unsure if this will work. Okay, so it's in, and there we go. So it did actually work. Perfect. So now you can see I'm in Meterpreter, and let's see the commands for Meterpreter. Okay, there is not actually access to webcam on this Windows server, so I'm not going to look at that, but okay, so let's say I can take a screenshot. So it saved this screenshot to my root, and here we have, which one did I call it? That was one from a previous one. Oop. Yep, this one. And you can see, give it a second to open. And there you have it. So I actually have remote access to this Windows server. And I can do a variety of things as shown in the usage. I can use a shell script to run commands on its terminal. I can try to get its system information. I can execute a command or get code. I can record the keystrokes that are done on this. There are so many things that can be done with Meterpreter. But that on the whole is how EternalBlue uses the SMB vulnerability to gain access to a Windows server. Okay, thank you so much for watching. Sorry for the technical difficulties in the middle.